Hello, my name's Julian Edgar and I'm the author of this book, Designing and Building a New Energy Efficient Home. What I want to cover in today's video are some of the massive misconceptions about thermal mass. Let's take a look. So thermal mass is just surrounded by misconceptions and plain outright BS. And that includes from supposed experts giving highly paid advice. I have never seen more rubbish about any aspect of passive solar design until it comes to thermal mass. So we're going to look at a few of those misconceptions in this video. But first, what is thermal mass and how does it work? So thermal mass is anything positioned inside the insulated envelope of the house that stores heat. You can also think of it as storing cool, doesn't matter which way you think about it. In our house, the thermal mass comprises mostly the concrete slab on which the house is built. It was built exactly as specified by the engineer for the site, except it's had an added layer of insulation placed around the outside edge, nothing underneath. We also use water as thermal mass in our house. It's in these tanks. Water works very effectively at thermal mass because it needs a lot of energy to change the temperature of 1 kilogram or 1 litre of water. And finally, in our house, we have a few brick feature walls, and they weren't really put there for thermal mass. They're a bit like the slab. They were put there structurally and also because we like the look of them. So each of these substances can absorb heat from the air inside the house or give heat back to the air inside the house. So let's have a look now at how thermal mass works in both summer and winter, and then we'll get to some of the misconceptions. So in summer, the thermal mass, the concrete slab and anything else like it, absorbs heat from inside the house. It absorbs heat from the air inside the house and therefore it keeps the air cooler. Now the thermal mass rises slightly in temperature, of course, as it's doing that, but because it has such an enormous capacity to absorb energy, the temperature rise is actually quite small. But it has stored the heat and we need to get rid of that heat before the next day, and typically we do that by opening the house at night, letting the cool night air come through and remove the heat it has stored from that day. So to work, thermal mass in summer needs sufficient diurnal range. It needs a climate where the maximum temperature of the day is quite a lot higher than the minimum temperature at night, at least 10 degrees Celsius difference. What about in winter? Excuse me. In winter, the thermal mass absorbs heat from sunshine that enters the house. So we have our northern windows, we have them unshaded in winter, we have the winter sunshine coming in, and it warms the thermal mass, which then stores that heat. And when the inside of the house would otherwise start getting cold, like at night, the heat gets released automatically from the thermal mass and it keeps the inside of the house warm. So for winter thermal mass to work, it needs the entrance of winter sunshine. Now, if you're thinking to yourself, well, that's all pretty easy and pretty straightforward, it is. There's no rocket science about any of this. It's very, very simple to understand. And that's one of the puzzles about why so many people have misconceptions about how it works. It's not a complicated idea at all. So the first misconception is thermal mass stops working after a few days of the wrong weather. So in winter, that would be, well, no sunshine's coming in for a few days, it's cloudy, therefore the house will be really cold. Or in summer, which is the example I'm going to use here, after a few hot days, the thermal mass will be hot, so the inside of the house will be stinking hot. This is quite wrong. Or it is right only when the thermal mass is completely insignificant. It's insufficient. There's not enough of it. It's a badly designed house. So I've got an example here from summer. For the rest of this video, I want to use graphs that show actual performance, actual logged performance of a house with thermal mass. So here we have 5 hot days. The green line shows outside temperature, nearly 36, day 1, 36, day 2, 39, day 3, next day 41.7, next day over 38, nearly 39, next day over 38. So we have 5 really hot days in a row, and according to the experts, this would mean the thermal mass was stinking hot, and therefore the inside of the house was stinking hot. So there's a few problems with that. The first thing is, remember, you open the house at night to cool the thermal mass, and the red line shows the temperature of the thermal mass, and you can see that each night when it's opened, it drops a little bit. Now, it doesn't drop a lot in this case because the nights are fairly warm. Look at this night here. The night is over 22 degrees. That's pretty warm for this area. So these are bad circumstances for thermal mass. We have multiple hot days, very hot days in a row, and the coolest it gets to 12 on the first night, which is great, but then as it goes on, it's more like 18 or 20 overnight. So again, according to those experts, the thermal mass is going to be stinking hot. Well, here is the actual logged data, not made up. The thermal mass is 22.5 degrees Celsius after 6 days over 34. Now, the inside of the house, the temperature of the inside of the house won't be the same as the thermal mass. It'll be higher, and we can see here it's just over 26, so it's about 4 degrees higher than the thermal mass. But the inside of the temperature of the house is still massively moderated by the presence of that thermal mass. It's still dragging the temperature down enormously. After all, the inside of the house isn't 38, is it? It's only about 26.5. So, excuse me, this is a perfect example of that misconception being a misconception. Thermal mass stops working after a few days of the wrong weather. Rubbish. Absolute rubbish. Same applies in winter. You have 3 or 4 days of cloud. Yes, the thermal mass will be dropping in temperature, but it'll still be working. If it's naught outside, suddenly the thermal mass won't be naught. It'll be more like 18 or 20. And that'll be lifting the temperature of the air inside the house. So as soon as someone says this to you, and I see it time and time again, thermal mass stops working after a few days of the wrong weather, ask them where their evidence is, and they will have none. Another misconception, and I've seen this from people who should know a lot better. Only the top 50 millimetres of a concrete slab does anything. Well, no, that's not right. Here I have the logged temperature of the concrete slab, and the slab sensor, that's the red line, the slab sensor is 75 millimetres deep inside the concrete. Okay, the slab's about 150 millimetres thick, so approximately halfway through. It varies a bit, so halfway through the slab thickness. We can see, if we look at the days along the bottom axis, we can see that at 75 millimetres depth, the concrete slab is varying in temperature on a daily basis. It is part of the thermal cycle of the house at 75 millimetres depth, and it would be a pretty astonishing physical circumstance if at 80 millimetres suddenly it wasn't doing anything. Okay, if suddenly it all just stopped at 75 millimetres. Obviously it doesn't. The whole slab is involved in the thermal performance of the house, and in fact the soil under the slab, because the slab isn't insulated from the soil under the slab is also part of what the slab is doing. Now, it might look like it's varying a lot here in temperature, but the scale is only 0.2 degrees Celsius per increment. And so, in fact, it's really only varying here across the whole lot from about 20 to about 21.3. Okay, so it's only varying by about 1.3 degrees Celsius over that whole time frame, but we can see it is involved in what the house is doing at 75 millimetres depth. Now, the top line is actually the temperature of the water tank that I showed earlier. You can see that it varies by a greater amount, which is what you would expect. It's fast response thermal mass, and you can see as it's in the room, it's completely exposed to air in the room. It also is higher in temperature typically than thermal mass, which is connected to the ground. Only the top 50 millimetres of a concrete slab does anything. That is simply wrong. Where is the evidence? Ask them, they will have none. Oh, well, that's what I heard, or that's what I read once, or, well, aren't you making any measurements? Where's your data to support the misconceptions that you are suffering from? Let's have a look at the next slide. Misconception. in winter. Only thermal mass that's in the direct sunshine does anything. That's simply not true. And in fact, this misconception is so widespread that sometimes you see people who carpet the slab on the southern side of the house but leave it exposed on the north. Now, as soon as you carpet a concrete slab, cover it in underlay and carpet, you are insulating it from the house, and so therefore you are reducing its ability to exchange heat with the house. A concrete slab, to be effective as thermal mass, cannot be insulated from the house. Therefore, it needs to be polished concrete, or it needs to be ceramic tiles, which are in intimate contact with the concrete slab. So only thermal mass in the direct sun does anything in winter? No, that's not true. So what we have here is we have a data log. We have the green line showing outside temperature. We can see it gets down to 2 degrees overnight there. It gets to 3 degrees overnight there. It gets to 5 degrees overnight there. This particular day has a peak of 21. So this is certainly a winter or near winter logging. Now, the red is the northern slab, which is exposed to direct sunshine coming in through the windows. Great, you can see it's sitting around 20 degrees in winter. 20 degrees, think of how that's pulling up the temperature of the air in the house. It's 2 degrees outside, it's 20 degree slab that you're exposed to. But the key point here is the purple line shows the southern part of the slab, which is never in direct sunshine. Now, you can see that the purple line, the southern slab, the southern part of the slab, is cooler. It's cooler by about 1.5 or 1 degrees than the northern slab. But you can see it still varies in temperature just as the northern slab does. It is part of the thermal performance of the house. It is connected to the northern part of the slab. It's just one continuous slab by conduction. Heat gets transferred through the slab. The whole area of the slab is part of the thermal mass of the house. The whole area is working. Certainly, the thermal mass that's in the direct sunshine is warmer by 1.5 degrees C, but that heat is transferred through the whole slab. The whole slab is part of the thermal performance of the house, and therefore it should not be insulated anywhere in the house. Now, there are people who say, oh, I don't want to stand on a concrete floor the whole time. You can have rugs. You can have rugs distributed. Just keep in mind, the bigger those rugs, the more you're insulating that part of the slab. But look, small rugs will make no measurable difference whatsoever. Misconception, the biggest. Thermal mass doesn't do anything. This is just absolute and utter garbage. So let's have a look. What we've got here is we've got the green showing the outside air temperature. Drops to 2, drops to 3. It's the same period we saw a moment ago. We have the brown line showing the temperature inside the house. And we have the darker brown line showing the temperature of the concrete slab. Now you can see the concrete slab is sitting between about 20.5 or 20 there, sitting between 20 and 21 degrees. It only is varying by 1 degree overnight. So basically, let's just call it 21. Concrete slab sitting at 21. It's sitting at 21 whether it's 21 outside or whether it's 2 outside. Now you can see the enormous effect that having a whole floor sitting at 20 degrees is going to make to the air temperature in the house. And it pulls up the air temperature here to 18 degrees. So instead of 2 degrees inside the house, as it would be if it were completely open and it had no thermal reservoir, it's 18 degrees inside. Now you might say, oh, you must have good insulation. No, we don't. We have standard 7 stars Natters insulation, except in the 2 end rooms where we've got doubled ceiling insulation. But all the wall insulation is standard R2.7 that fits in a 90mm stud. In other words, didn't cost any more. It's the thermal mass that is supplying the heat to keep the house at a minimum of 18 overnight, even when outside it's dropping to 2 degrees. Okay, thermal mass is extremely powerful in absorbing heat in summer to keep the inside of the house cool and providing heat in winter to keep the house warm. And a key point that I make in these videos time and time again is it doesn't have to cost anything. If the concrete slab is part of the design of your house, excuse me, all you have to do is insulate around the edge and you've got that heat and cool storage reservoir available to you at no cost. That is dramatically different to saying, oh, well, you need special windows from Europe and you need special doors and you need a special ventilator and all these other special, exotic, costly things that you keep getting told you need. This house doesn't have any of those. Passive solar is about good fundamental design and not the sticking on of technological band-aids. Band-aids like special windows, special doors, special insulation, special ventilators, special ceiling, all these things that aren't actually needed if the fundamental design of the house is correct for a southern Australian climate. The book's called Designing and Building a New Energy Efficient Home. You can't buy it yet. It'll be out mid-late 2026. The reason I'm waiting for that time is I want all the logging for a year for this house. Now, I showed you a little bit of winter logging then, but I want to have winter logging right through winter. I've got summer, I've got spring, I want autumn, and I want winter. Thermal mass temperatures, air temperatures, relative humidity, dew point, radiant temperatures, you name it, I'm logging it. And that's the evidence that I want to be able to present in the book. The book is 90% written, but I'm waiting for that extra information before I publish. But remember, before you leave this video, thermal mass is an absolutely fantastic asset in an energy efficient passive solar home. Thank you.